Good morning, 5th grade. Today we are going to be talking about bodies in our solar system, including the moon, asteroids, comets, and meteoroids. On your desk you should have 3 papers. One is a pre-test, and then there's a notes handout, and then a post-test. And I want you to go ahead and take the pre-test. It's only 4 questions, and it's just to see what you know. So nothing to worry about. We'll go over the answers through the PowerPoint, and then you'll take the post-test at the end so we can measure what you've learned. So go ahead and fill out that pre-test. Okay, go ahead and put your pencils down, and we're going to get started. You have a note sheet, and there's 4 columns, one for the moon, one for asteroids, one for comets, and one for meteoroids. And as we go through each slide on the PowerPoint about each of those, I want you to take notes and draw a picture of each one, and you can hang on to that to study and look over. So we're going to go ahead and get started with our Tennessee Science Standard, which is ESS 1.3, and it says to use data to categorize different bodies in our solar system, including moons, asteroids, comets, and meteoroids, according to their physical properties and motion. Our first topic is going to be physical properties of the moon. The moon is very rocky and cratered. We actually have 214 moons in the Milky Way galaxy, which is what we live in. But that is too many moons to talk about today, so we're just going to focus on the one for our planet Earth. Our moon is 1/4 the size of Earth, and it is about 238,855 miles away. And that is a long way, but we can still see it with the naked eye, which means we can still see it without a telescope or anything like that. So we're going to go on. The moon has craters. It is filled with craters, and these are big holes that have been put in the moon because a comet has collided with it, and we're going to talk about comets later on. We're going to go ahead and go to the motion and phases of the moon. So the moon rotates on its axis just like Earth. It's like an imaginary line that the moon spins around. And as the moon is spinning around, it is also rotating the Earth while the Earth is rotating or orbiting the sun. So one rotation for the moon takes nearly the same time as one revolution around the whole Earth. And because of that, since they take the same time, around 27 to 29 days, the moon is always facing the Earth, so we can always see it. As you can tell, the moon is round, or not perfectly round, but it is a round shape, and if you look in the night sky, it might look like the moon is different shapes, but that is because the sun is hitting it at different points when it is around the Earth, and it is only lighting up either half of the moon or part of the moon. So we can see here, when the moon is between the sun and the Earth, it's a new moon that we cannot see any of the light. The sun is reflecting onto the moon, but whenever you move up, you can see a little sliver. It's called a waxing crescent, and then you can eventually see half when it's above the Earth, and then the cycle keeps going till you get to a full moon, and then the light starts to decrease back to a new moon, and it just goes on and on. So make sure that you have gotten that stuff down on your note sheet, and we're going to move on to asteroids. Asteroids are small and rocky objects that orbit the sun quickly. As they orbit the sun like planets, but they are not a planet, but they do orbit the sun like the planets, they are also spinning in themselves. They're very irregularly shaped, and they are cratered like the moon. Their surface is covered in dust. Some asteroids are even big enough that they have their own moons, and they all together orbit the Earth. Most asteroids live in something called the asteroid belt, and it is between Mars and Jupiter. And it has stayed there because of those planets' gravitational pull. The asteroid belt is in this picture. As you can see, it's between the orbit of Jupiter and Mars, and that is what kind of separates the inner and the outer planets. So that is where most of them are, although they're not all there, but a majority of them are. So go ahead and get that stuff down on your sheet and draw a picture of it. It looks like this. It looks kind of small in the picture, but it really is pretty big. Not as big as a planet though. Okay, we're going to go ahead and move on to comets. Comets are icy balls of frozen gases, rock, and dust. A lot of people call them or compare them to like snowballs, but they are very cold. They're frozen gases, and when they're frozen, they're about the size of a small town. And I know that sounds kind of big in comparison to where we live, like a comet could be as big as Jeff City, but whenever they're in space, everything in space is so big that really that is not very big in space compared to everything else. Comets also orbit the sun, just like asteroids and the moon and planets, but it is not the same thing. And whenever their orbit brings them close enough to the sun, they start to heat up and eventually they will explode, and the gases turn into a giant glowing ball of fire. So that is pretty interesting. If you guys want to go ahead and jot that stuff down and draw a picture of it. We will move on to meteoroids. Meteoroids are small bodies in outer space. You can kind of think of them like space rocks, like we have rocks and pebbles here on Earth. These are kind of like rocks in space. They're made up of silicone and oxygen and metals such as nickel and iron. They're about the size of a pebble or a rock here on Earth. They also travel around the sun, but they are not necessarily in our Earth's atmosphere. They are way up in outer space, but they do eventually come into Earth's atmosphere, and when they do, they turn into a meteor. So they come into Earth's atmosphere at a really high speed, they burn up, and they look like tiny balls of fire. So some of you may have heard or even seen a shooting star. A shooting star is actually a meteor or a meteoroid that has came into Earth's atmosphere and is now burning up, and that is what causes a shooting star. So a little project for you guys. Go outside every night and see if you can find a shooting star or see one. This will be extra credit. But it would be really cool to see one, and I want you to just jot down what it looked like, how fast it was, and that will be some extra credit on your next exam. And it will be cool to know now that what a shooting star actually is. Okay, now I want you guys to go ahead and, after you've finished your notes and finished your pictures, to put that stuff aside and grab your post-test. And just go ahead and fill it out. We have covered all the answers here in this lesson, and you're going to go ahead and take that, and then we'll go over the answers and see what you guys have learned. Okay, now we're going to go over the answers. So number 1, how big is the Earth compared, or how big is the moon compared to the Earth? We said that the Earth is about 1/4 of the size of Earth. So that is number 1. Number 2, what planets is the asteroid belt in between? We said that the asteroid belt is caused by the gravitational pull of Mars and Jupiter. So that is the planets that is in between Mars and Jupiter. And that separates, if anyone remembers, the outer or the inner and the outer planets is the asteroid belt separates those. Number 3, what are comets made of? We said that comets were made of B, frozen gases, and remember, whenever those gases get too close to the sun or their orbit takes them to the sun, they will explode and cause that big ball of fire. And then number 4, what are shooting stars? We just went over this. Remember, shooting stars are meteoroids. They will come to the Earth's atmosphere and it will create a meteor, and that is what a shooting star is, are those meteoroids that come into Earth's atmosphere. So go ahead and put your grade at the top, how many you missed, and we'll take those up. And this is not really a grade, it was just to show you guys how much you have learned throughout this lesson and give you a little bit of a measurement. But I do want you to hang on to your note sheet and use that for studying. I hope you guys had fun. Thank you.